So now these are log rank tests now. This time around also still the same thing. So don't confuse this. This was in preview. You can still use something like this too also, because it's already going to pick it from the data. As far as you have the columns time and date inside your data, you're still going to get the same thing. So I'm going to do a log rank test now, 0.001. So let's do for each group too also. Group was also printed results 0.09. See, for each group is the P was even written here already. If you notice, the P is even already there. So this is for the log rank test. This I can calculate your or perform your log rank test, which means in this place there is no significant difference between the various age group. So you can see that then we have pairwise comparison. So for each group, perform pairwise log rank test. So let's say the age group now, there is significant difference between them. They now want to know which of them actually have significant difference. You only use this when you have more than 2 levels. You have 3 levels, you have 4 levels to pick out that particular group, level in that factor that is significantly different. So you run the pairwise log rank test. So just run it like this. So you can see the result of the pairwise log rank test now. So you can see it. Though our age group was not actually significant, I'm just using this to explain to you. Now you can be able to know which particular age group is significant. For example, I can have this one now to be 0.06. This will now tell you that this and this are actually significant difference with each other, but this and this are not significant difference with each other. So this is the use of the pairwise log rank test. So for the Cox-Proportional hazards model, how do you run the Cox-Proportional hazard model? So for the Cox-Proportional hazard, it's very simple. If you are just trying a univariate model, you just use the Cox-PH function. You give your survival object here. You see, for this is for 6, and just like we did it earlier on, you just change it to Cox-PH, and you just run this. For this is for 6 now. I'm running it individually. So I'm going to run it individually for each particular factor we are trying to look at. You can try out other factors. So we have for sex here. Can you see that of sex? So the key things we are trying interested in now, we're interested in the exponential coefficient, which is the odd ratio, and also the p-value. So you can see this is significant. So which means that what female have a 58% lower odds of experience of dying compared to male. This is what it means. Or the odds of female surviving is 0.58 lower than that of male. We also have for that of age group. For age group, you can see that it is also significant, and though in this particular place we use age instead of age group, so it is significant. So which means that we use the continuous variable in this place instead of using the age group, which means that the higher the age, then the higher the odds of experiencing death by 1.02. So we can go further to check and just use age group. So you can see in terms of age group now, it is actually greater than 70. This is the advantage of categorizing your variables. So for that of age group, the p-value of 61 to 70 compared to less than 60, which is our reference category, is actually high and is not significant. But for that of greater than 70 is significant, which means that the odds of dying compared to those that are aged less than 60 is 1.56. So this is the odds ratio. Then we have that of the pH.ECOG. So you can also see it. So those with a higher pH.ECOG level, the risk of them dying is 1.61 higher than compared to those that have a lower pH.ECOG. So it's actually significant here. This is how you interpret your Cox-Proportional hazard. So you want to do a multivariable one. So we're just going to prepare the values without missing values here, as you have seen. Then for a multivariable one, you just combine all of them together instead of putting single ones as we did earlier on. Combine them together and you run it. So once you just run it here, you're going to be seeing their true hazard risks or hazard ratio controlling for other factors. To control for other factors, only two are significant: the female level under sex and pH.ECOG. So you can see that for the female level under sex now, you can see that it is actually significant, and females have a lower risk of dying compared to male. So those also with a higher pH ECOG have a higher risk of dying compared to male. So I try to make sure that we don't have one. If you have one, it means it's not significant. So that's what we're just trying to signify. Also, even in our confidence interval, it shouldn't be between 1. You can see that this one is containing 1 in between. This one is also containing 1 in between. But there is no 1 in between this confidence interval. So this is the key to understanding how to interpret your confidence intervals. For a model with interaction, this is a model with interaction. So you can see we are interacting pH, ECOG, and sex. So I'm just going to run this. So you can see for a model with interaction now, this is it. Sex, female, pH, ECOG is not actually what's significant. But let's say it is significant. Then we're going to interpret it just like we did in the previous sections, which means that what for individuals that are female with a higher pH date or ECOG, then the risk of them dying is higher compared to those that are male with a lower pH dot ECOG. So this is how you interpret your interaction, because that means the effect of the risk of female dying is going to be influenced by the factor pH date ECOG. So it's possible the higher pH date ECOG can increase the risk, and the lower pH date ECOG for female can reduce the risk. So if you want to visualize your Cox models now, I'm just going to be using this particular code, GG Forest. It's going to now give you your Cox model in terms of the visualization. So if you look at it carefully now, you can see we have our H, we have our sex, F, pH.ECOG, and pH.Cano. And I already explained this diagram in the previous lecture. So this is how you get this particular diagram using the GG Forest code. You can see you can just use your Cox model here, your data, your title, and the font size.